Good morning, dear student. This is Professor Indu Shrivastava, Department of Computer Science and Engineering, SIRT Excellence, Bhopal. Today we are going to study about the continuation of your subject, that is discrete structure, CS 302. And today we will going to cover your topic, that is set theory, right? So let's start. First of all, what is set theory, right? Here you can see the definition of set theory. A set theory is defined as a collection of distinct objects of the same type of class of objects, right? And the purpose of a set are called elements or member of the set. An object can be a number, alphabet, names, etc. So basically, set is the collection of distinct object, that means different kind of object, right? So here we discuss, let's take example to better understand. Here you can see the example of the set of rivers of India. So this is the element set of rivers of India. So this is the set of the rivers, right? So this is the also part of the set theory. And also we take one more example, that is the set of vowels, that means A, E, I, O, U. It involves the alphabets, but a particular type of alphabet. So which type of alphabets having in this set? Vowels, right? And so many examples are set theory. So here we discuss about the set theory, how many types of set theory, what are the notation of set theory, how to represent set theory, right? So let's in the continuation of the set theory, here we discuss about the set representation, how to represent the set, which kind of set we can represent which type, right? So here we can represent the set basically two types. First one is the roster or tabular form. In this form of representation, we list all the element of the set within the braces. Here you can see the braces and separate by them the comma, right? Here we take one example how to we represent the set in a roster form or tabular form. If A is a set of all odd number which is less than 10 in the roster form, here we can write like this: A equal to curly braces 1 comma 2 comma 3 comma 1 comma 3 comma 5 comma 7 comma 9, curly braces closed. Here we take this integer because we know the condition ki how many type of integer we can use or how many type of number we can use. Here given the condition, all number should be odd and less than 10. That's why we are taking this kind of set, right? Also in the representation of a set, in the continuation of the representation of set, we discuss about the set builder form, or we also known as the set builder notation, right? In this form of representation, we list the property fulfilled by all the element of set. And here we note that the as curly braces x colon x satisfied all the a property of P. And we read like this: the set of those entries X such that X has property of P. Here we take one example to better understand, right? So if B is the set of 2, 4, 8, 16, 32, then the set builder representation will be written like this: B equal to curly braces X colon X equal to 2 to the power N, where N is the belongs to capital N. Capital N, that means all the natural numbers. And that small n contained the value greater than and equal to 1 and less than and equal to 5, right? So if we are taking small n to the power 2, then we can get the answer of 4. The 4 is the element of that set B. Here you can see 4 is also available. So this is the representation of set builder. In the continuation of set theory, we discuss about the how to represent and how many types of numbers and notation we are using in a set theory in future. So here we write X belongs to A, that means X2 belongs to A, or we also read the X is the element of a set A. If we write X is not belongs to A. So here some notation when we are solving the set theory problem, then we should know uh, which set belongs to representing the which element or alphabet. So phi empty set is also written like this. Universal set is denoted by the U. Capital N is denoted by the all natural numbers. I is denoted by the set of all integers. I naught is denoted by the set of all non-zero integers. Integers तो होंगे but non-zero integers. I plus equal to all the set of positive integers. C comma C0 equal to the set of all complex number and non-zero complex number respectively. Q comma Q naught comma Q plus. This is basically belongs to rational numbers, non-zero rationals, positive rational numbers respectively. And R comma capital R0 comma R plus, set of all real non-zero and positive real number. So these are the some universal or some notation, standard notation which is used to in a set theory when we are solving some problem, some equation. Then we will going to that numbers or that notation to solve the set theory. In the continuation of set theory, we're going to discuss about the cardinality of a set. So what is cardinality? Cardinality, that means the total number of unique elements in the set is called the cardinality of a set. That means the cardinality of the countable finite set is called the countable finite cardinality. Here we take one example to understand what is the cardinality of set. Let assume P is a set which is contained the four element K, L, M, N, right? So in this set having the cardinality of 4. तो we basically coordinality होता क्या है? In cardinality how many elements will be going to used या will be have in that set. So that total number of elements is called the cardinality of the set. Let take one more example. If let set A is having 1 2 3 4 5 6, that is then cardinality number is the infinite, right? In the continuation of set theory, we will going to discuss about the types of set, how many types of set, and what are the notation and how to represent the set. So let's discuss discuss in detail what is how many types of set, right? So first of all, we will going to discuss about the finite set. What is finite set? A finite set is to be a finite. It contains exactly n distinct element where n is a non-integer negative values. Here n is said to be a cardinality of a set, and the cardinality of a set is denoted by the this, right? So let's take one example. Cardinality of the empty set is 0, and which is denoted by the this, right? Here you can see the this, right? Next we will going to discuss about the infinite set. A set which is not infinite is called the finite set, right? Infinite set. So basically two types of infinite set. First one is countable infinite and second one is uncountable infinite. So what is countable infinite? If there is one-to-one correspondence between the element in the set and the element of all natural numbers, and a countable finite set is also known as the denumerable right? And a set that is either finite or is known as the countable set. And also in other word, we can say that a set which is not countable is known as a uncountable set. So the set of non-negative even integer is countable finite set, and uncountable finite set. So uncountable finite set which is not countable, right? So if we are not countable any integers, then it is called the uncountable finite set, or non disnumberable finite set, right? So here we take one more example to understand. Set of all positive real number less than 1 can be represented by the decimal from 0, A1, A2, A3, where A1 is the an integer such that 0 is less than equal to AI, and AI is less than equal to 9. So this is the infinite set condition. After that, in the continuation of set theory, we're going to discuss about the subset. So what is subset? If every element in a set is also an element of a set B, then A is a subset of B. Here it can be denoted by like this. A is the subset of B. A is the subset of B. Here B is called the superset of A. Let's take one example to understand. Here you can see the if A set A is having 1 and 2 and set B is having 4, 2 and 1. So we can say that A is the subset of B, but B is not is the subset of A, right? So here we write like this: A is the subset of B. So, and also we discuss about the property of subset. So every set is a subset of itself, right? And also we can say that the null set of a null set is the subset of every subset. And also we discuss about the proper in the continuation of property of subset. If a if A is a subset of B and B is the subset of C, then it will be the subset of C. So here we write like this: A is the subset of B, B is the subset of C, equivalence. So C is the subset of A is the subset of C, right? So this is the subset, how we represent and how we return subset, right? And in the continuation of types of set, we will going to discuss about the proper set. So what is proper set? If A is a subset of B and A is not equal to B, then A is said to be a proper set of B. If A is a proper set of B, then B is a not subset of A. That means there is at least one element in which is not in A. Let's take an example to understand. If A is having 2, 3, 4 number and B is having 2, 3, 4, 5, then we can say that A is the proper subset of B, because B is having all the element which also contained in A. So here we can say that A is the proper subset of B. And also we already discussed, I already told you if null is the also proper subset of every set, right? So here we discuss about the proper set. Uske baad, after that we'll discuss about the improper set. If A is the set of B and A is equal to B, then A is said to be an improper set of B. Here let's take example to better understand. A is having the value 1, 2, 4 and B is having 2, 3, 4, 2, 3, 4. So here we can write A is an improper subset of B. And also we can say that the every set is an improper subset of itself, right? So here we discuss about the improper set, and in the continuation of the set theory, we're going to discuss about the universal set. What is universal set? If all the set under the investigation are a subset of a fixed set, that is U, that is universal set, then the set universal is the U is the called a universal set. For example, in a human population studies, the universal set consists of all the people in the world, right? So this is the universal set, because all people having their own identity, their own health, height, their own complex and unique property. So this is involved, yeah, this is involved as we use the universal set. After that, we'll discuss about the null set, or we can say the empty set. A set having no element is called a null set, या void set, या empty set, which is denoted by zero को काट देते हैं, तो that is denoted by 5. That is denoted by like this. After that, we'll discuss about the single tone set. What is single tone set? It contained only one element and which is denoted by curly braces के अंदर s. So here we discuss, let's take an example to understand. S is the set and which is having the element of 1, that is 8. So here we called this kind of set, we call the single tone set. After, in the continuation of set theory, we're going to discuss about the equal set. What is equal set? Two set A and B are said to be equal and written as A equal to B if both have the same element and same value. Therefore, every element which is belongs to A and also an element of B, right? And every element which is belongs to B is also an element of A. So here we written like this: A equal to B and X is belongs to A. Similarly, X is belongs to B. That means ki all element which is belongs to A and all elements which is belongs to set B. And if there is some element in a set A that does not belongs to B or vice versa and does not belongs to B, so A is a equal set of B, right? In the continuation of set theory, we're going to discuss about the equivalent set. So what is equivalent set? If the coordinalities of two set are equal, they are called the equivalent set. For example, if A is having 2, 1, 2, 6 and set B is having value 16, 17, 22. So they are equivalent as a cardinality. Yes, of course, they are equivalent because here we discuss about the equivalence. Doesn't matter which kind of value content, matters that both set are having same cardinality number, right? So here we A is equal to the cardinality of B. That means कि दोनों की cardinality number 3, right? So here we discuss about the set theory, cardinality of set theory, and how many types of set theory. In the continuation of set theory, we're going to discuss about the disjoint set. What is disjoint set? Two sets A and B are said to be disjoint if no element of A is in B and no element of B is in A. Here, let's take example. If a set R is having A, B, C, and one more set S that having K, P, M. So set R and set S are disjoint because both set having different elements. So we can say that this set are disjoint, right? In the continuation of set theory, we're going to discuss about the power set. So what is power set? The power set of any given set A is a set of all subset of A and B, A and is denoted by capital P in bracket A. If A has an element, then we can write A bracket A. It has been written like 2 to the power n element. Let's take example to better understand what is power set. If a set A is having 3 elements, 1, 2, 3, that means what is power set? Power set is having 2 to the power n. That means total number of pair build 2 to the power n. That means 2 to the power 3. That means 8. So here you can see the you can see the element that is 5, 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. So this is the power set. Today we'll have discuss about the set theory, what is set theory, how many types of set theory, and what is cardinality number. So thank you very much for listening patiently.